specialize in highly engineered components, manufacturing systems, specializing in metallurgy. The future of manufacturing is not just subtractive manufacturing, but additives. You've got foundry, machining, welding applications, forging applications, but now we're looking at taking components that are standard components and doing additive manufacturing to them. We're looking at a cleaner carbon footprint because we're not wasting as much material. We got 99.9% utilization. We end up expanding components. You're able to create components on a machine on the fly with a very fast turnaround, which is the best application for both the testing of the components, the viability of them, and you're going to start seeing the world start to progress a lot quicker. This is the future of manufacturing. Some of our customers end up starting with a 200-pound block of aluminum, and they machine it down to 35, 40 pounds for a manifold for a very light application. We would start with a 20-pound block of aluminum, add the material up to 60 pounds, reducing the machining time from 40 hours down to 4 or 5 hours, and creating much less waste. We started developing the project recognizing that the capability of the software could be very high. We proposed it to the people at KUKA. They were very interested. They provided us the platform to put together this demonstration system. The capability of the system is great in comparison to either powder material or casting applications. We're looking at roughly 1 to 20th to 1 to 25th the price of powder, because the cost of the material for a powder material is $12 to $25 per ounce, where the material that we're using in these applications are $3 to $15 per pound. In the wire application. Plus, we have many more different metallurgical characteristics in the wire available as a standard product than you would in a powdered component. Our deposition rates are also 20 times faster. It's one of the strong characteristics of this project is it has capability with exotics. The standard steel is something that is certainly within the capability of the equipment, but because we have such great temperature control through the laser and dimensional control through the KUKA robot, we're able to provide a layer by layer combining of the existing wire material in stainless steel, Inconel, cobalt, high nickel alloy, carbide, and that also provides us the capability to put 2 or 3 different materials into the same component. So we can start with a soft, strong substrate and finish with a hard, wear-resistant casing on the wear characteristics part of the component. It's a whole different way of looking at manufacturing, that you could take components of multiple materials and manufacturing speeds and bring them to market much faster. The type of components that we think are the best fit for this is low volume, high mix, very complex components of a complex steel format. So we're looking at components for ships, airplanes, suspension components, prototyping, replacement parts. Let's say that you have an agricultural company with a large inventory of components for obsolete replacement parts. We will provide you a component based on the repair of that component. You provide us a 3D model for it. We provide you the component made out of the correct material within a day or two.